Hello, and welcome to today's algebra lesson. We are at the end of a series of 3 videos dealing with slope. In the first video, we talked about how to calculate slope from 2 points and what it means as far as a positive slope, a negative slope, a zero slope, or an undefined slope, and what those lines look like in their general direction. In the second objective, we looked at how to use slope to show that lines are parallel. Parallel lines have the same slope, so if you calculate the slope for one line and then calculate the slope for another line and the numbers are the same, then they are parallel. There's another thing that slope can show us about lines. They can show us when 2 lines are perpendicular. By perpendicular, we mean they meet at a right angle. It's not going to be that easy for me to draw, but the most famous perpendicular lines are the y-axis and the x-axis. Now, that's not exactly a neatly drawn right angle, but these are perpendicular to each other. The 4 angles made when they cross are all the same. They're all 90 degrees. So there is a way to, now the x-axis and the y-axis, the x-axis and the y-axis are just one case of perpendicular lines. You can have other lines at other directions. So let's say we had a line here, and then a line here. They can be perpendicular also. These are 90 degrees. There is a way to tell, using slope, whether 2 lines meet at a 90-degree angle or whether they are, as we say, perpendicular. In some places you'll see the word normal. That tends to be more for when like planes meet, but normal is another word for perpendicular. So what you notice about this line here, the one I'm going back and forth on, that has a positive slope from what we learned in the first video. It starts the bottom, moving left to right, you're going up. And notice that the line perpendicular to it has a negative slope. That is true for all perpendicular lines that are not the x and y axis. So the sign of 2 perpendicular lines would be different. In the case of the y-axis has no slope because it's vertical, and the x-axis has undefined slope. No slope is perpendicular to undefined. But we're not really going to deal with that here. We're going to deal with the case of lines that are not horizontal or vertical. So if 2 lines that are not horizontal or vertical are perpendicular to each other, one would have a positive slope and one would have a negative slope. That's always going to be true. That's something to keep in mind. So here are the real rules here. If 2 non-vertical lines are perpendicular, the product of their slopes, what does product mean? It means you multiply. So if I have one line with a slope of 3 and another line has a slope of negative 1/3, if I multiply those together, remember when I multiply a fraction times its denominator, so I have a denominator of 3, I'm multiplying by 3, I'm left with just the numerator, I get a negative 1. So if I had a line whose slope was 3 and another line whose slope was negative 1/3, I multiply the slopes together, and if I get a negative 1, they are perpendicular. Now I know they're not parallel because 3 and negative 1/3 are not the same, so I know they're not parallel. So I would check that first, but if I multiply them together and I get a negative 1, they're perpendicular. If I multiply them together, like if this had been a 2 on top instead, I would have got a negative 2, then they're not perpendicular and they're also not parallel. So that is how you tell if 2 lines are perpendicular to each other. You multiply the slopes together and see if you get a negative 1. A horizontal line is always perpendicular to a vertical line. That's the exception case when you don't have a slope. So I want to show that the line passing through these 2 points, negative 1,4 and 3,2, is perpendicular to the line passing through these 2 points, negative 2, negative 1, and 2, 7. The line through negative 1,4 and 3,2, I calculate the slope like this. It looks like I said this is x1, y1, x2, y2. I do y2 minus y1, 2 minus 4, x2 minus x1, 3 minus a negative 1, and you get a positive 4, negative 2/4, or negative 1/2. So the slope of my first line is negative 1/2. I'm not ready to draw a conclusion. I have to find the slope of the other line and then multiply them together. So the line from -2, -1 to -2, 7, x1, y1, x2, y2, y2 minus y1, x2 minus x1 on the bottom. So remember 2 minus a -2, that'll add 7 minus a -1, that'll add to be an 8. I get a 2. So for the first line, I had a slope of -1/2. This line, I have a slope of 2. When I multiply those together, I get a -1. So these lines are perpendicular. And if I plotted the points and drew them, I would see that. So other examples of lines that would be perpendicular. So if I got something besides a -1, the answer is no, they're not perpendicular. So you have to do the calculation for each line, multiply, and then answer the question, are they perpendicular or not? If I had 3/2 was the slope of one line, and then I had -2/3. Sorry, I meant to make that a parenthesis. -2/3 is the slope of another line. If I multiply those together, 3 times -2 is -6. 2 times 3 is 6. I do indeed get -1. So that would be another example of the slope of this line is 3/2. The slope of the second one is -2/3. Those lines are perpendicular. If any of these numbers are different, they're not perpendicular. If you get anything besides a -1, you might also be seeing a pattern that if my slope of one line was 3/2, if I want a slope that's perpendicular to it, I flip it around to 2/3 and change the sign. That's always true. If I start out with a slope of -1/2 and I want to be perpendicular to it, I change the sign to a positive and I flip the slope over, or write what we call its reciprocal. So -1/2 slope is perpendicular to a +2 slope. 3/2 slope is perpendicular to a -2/3 slope. You may see that again later when we're finding equations of lines. But for now, you just need to know that I find the slope through each set of points, multiply them. If I get a -1, they're perpendicular. If I don't get a -1, they are not perpendicular. If I calculate the slope between two pairs of points and find that slope was the same, they're parallel. If it's not the same, they're not parallel. If you multiply those slopes and don't get a -1, they are neither parallel nor perpendicular. The three choices are: the lines are parallel, meaning the slopes are the same; the lines are perpendicular, meaning when you multiply the two together, the product of their slopes gives you a -1; or neither of these two things are true. So, most lines will be neither, although in your homework certainly there'll be more that are parallel and perpendicular, just to give you practice with that. Okay, so I hope this is helpful, and just email me your questions and we'll see you next time.